Today I am going to talk about functions in Python. Functions is basically a modular approach to programming. That means we break a large task into small segments. Each of these segments in Python we call it a function. Now what actually basically happens is the benefit of using these small modules is the reusability of code. So a function, we can define it as a reusable code that can be, that may contain a group of statements for execution. I'll give you a small example of how to create functions in Python. All functions in Python will begin with the keyword def for definition of the function. So definition, let me name the function as func, func, and let's have this, a function without any parameter. I'll tell you the meaning of a parameter exactly, and here let me print a message, print hello. That's it, only this much. Now, this is the portion from where the main program begins. I'll explain you the meaning of this. This is just a comment I have written over here. So, suppose I call the function func twice. Now, let's see what is going to happen out here. This is the definition of the function, so therefore the execution do not begins from here. It begins from this particular area. And the first statement, what I have written out here is the func. That means I am calling the function named func. So what actually happens is the entire control gets transferred over here. All the statements in the function gets executed, normally just like a small program. So out here we had just a single statement, print hello. So it's going to display the word hello on the screen, and then it gets back to the next line wherever you have called. So in the next line, again we have a call to the function named func. So again the control gets transferred over here. It displays the word hello. So hello gets displayed. And then again it gets back over here. Now since there is no more line, the program ends. So you can see the same function is being called twice or invoked twice. So now let us understand the structure of the functions in Python. So in functions in Python should be defined first. That means what should be the function doing? The task should be given first, and after that you need to call the function to perform that particular task. So here I am calling this function twice. This is what I said earlier about reusability of the code. If we have 10 lines over here, this was a very simple example. If we have 10 lines over here, I don't need to write 10 lines out here and here, making it 20 lines altogether. I just need to call it twice to execute all these 10 lines. So resultant is all the 20 lines gets executed using simple function calls. Now what we are going to do is, we are going to understand how to pass some values to a function. To pass values to a function, we use parameters. I'll give an example. Now let us see what is happening over here. I have defined a function which takes two elements as parameters. You can see there are two values, a and b. These are called parameters, or strictly speaking, they are called arguments. So these are called arguments or parameters. This is to take values from outside the function environment. So if we want to pass some values from outside the function environment, we use such arguments or parameters. So we have two parameters over here named a and b. What I am trying to do out here is I am trying to find the sum of the two parameters and store it in C. Next, I am displaying the value of C. Now look at the main function. This is very important. I have over here function called func 5, 6. So what I am doing is, this time since we have two parameters, we need to pass two values to those two parameters. So I am passing 5 to the first parameter, that is variable a, and 6 to the variable b. So the value of a and b is 5 and 6 respectively. So c equal to 5 plus 6 will give me 11. So print sum equal to c will definitely display sum equal to 5 plus 6, that is 11. And after that, once again, the execution comes to the next line. And function 7, 8. This time 7 goes to variable A and 8 goes to B. So it goes corresponding values to the corresponding variables. And now 7 plus 8 is 15. Print sum equal to C. So it's going to print sum equal to 15. See how simple it is for adding the two numbers out here. We call it repeatedly more than once, and every time we do that, we pass two values because it has two arguments or parameters to be received from the function, from the main part. Now, every variable that you declare inside a function, its scope is limited only within that function. What do I mean by that? Suppose, say for example, I have something like this. Now look at this function definition. I have a local variable named A, which is initialized with the value 7. Now this is local in the sense that its scope is only limited within this function named func. I also have a variable named A, which is initialized with the value 9, whose scope is limited only outside the function, that is out here only. Now you can see what is going to happen. The program execution begins over here. A equal to 9, print A, so definitely it's going to display 9 as the first output. I'm making a function called func, so the control gets transferred over here. A equal to 7. This A has nothing to do with this A. This A is local to this function. It occupies a separate memory location. Print A, so definitely it's going to print 7. Now when it gets back to the next line, print A, here the value of A is still 9, so it displays 9. In case it is necessary to share a variable to all the functions, you may have multiple functions in a program. If you want it to be shared by all functions, then we use a global variable. That means we use a variable which is defined at the top. So suppose I write over here A equal to 9 instead of 8. Now let's see the difference. You see over here A equal to 9 indicating that it's global. In other words, it is being shared by everyone, the functions as well as the main segment of the program. Now you see what happens is print A, so the value of A is 9, so therefore it displays 9. I make a call to the function named function, so it comes over here, print A. Before doing that, let me do something, let me change the value of A to 7. So it's going to print 7. Whenever we have a variable named A inside a function whose name matches with the global variable, this occupies a separate memory location. So print A is going to display 7 because the value of A is still 7. So therefore, when I print A, it's going to print the global A, that is, it's going to print 9. So what actually happens is, if we have a same variable whose name is same as the global variable, it gets more priority and therefore it prints 7. Although it looks like that this A is actually changing the value of this A, but this is not. It is occupying a completely separate memory location and this A is local to this function only. However, in case we needed to mean that this A is actually the global variable A, we need to use the global keyword. So what we do is, we write it this way, global A. Now, any reference to the variable A actually means the global A. So here when I write A equal to 7 and print A, now see the difference in output. We begin from here, print A, so it's going to print 9. Function call, it comes over here. Global A, that means any reference to the variable A means the global A. So A equal to 7, so this A changes to 7. So print A, it prints 7. Now when I come over here, print A, since the global variable A has changed to 7, it's going to definitely print 7. So this is how it works. Therefore, all local variables are localized to that particular function only. In case a variable name matches with the name of a global variable, it gets more priority inside the function. Any reference to that variable means the local variable. In case we need to refer to the global variable, what we do is we use the keyword global followed by the variable name. And therefore, any reference to that global variable is reflected out here also in the main function. I am going to perform a certain mathematical operation. That means I'm going to add two numbers and find their sum. Now look at this piece of code. This is a function which is accepting two numbers as parameters, finding their sum and returning it. Returning in the sense it returns a value. A function can return just a single value, and this value will be returned to the place wherever it was invoked. Now look at the main function, p equal to sum 5, 6. Now forget about this part. Let's see this. Sum 5, 6. The name of the function is sum. The value 5 goes to variable A. The value 6 goes to variable B. So C equal to 5 plus 6, that is 11. Return C is going to return 11. Now as mentioned earlier, it's going to return the value to the place wherever it was invoked. So the value 11 will be returned out here. So this entire thing gets replaced by the value 11. So P will be 11. Print P, it's going to definitely display 11. Now look at this. P equal to sum 7, 8. Same thing happens. 7 goes to A, 8 goes to B. C equal to 7 plus 8, that is 15. Print return C is going to return 15 where? To the place wherever it was called. So this place will be getting replaced by 15. So P will be 15. So print P is going to display 15. From here we understand the return statement is used to return a single value from a function. And once the return statement is executed, no other statement beyond it gets executed. That means return has two purposes. Return is going to return a value to the place wherever it was invoked, the function was invoked, and also it is used to exit from a function. Now let's do a much more practical example where we are going to take a number as parameter and find the sum of the digits. And in the main, I'm going to accept two integers as parameters and find the sum of the digits of each of these numbers. Now look at this example which I've written out here. This function definition is which accepts a number as parameter and find the sum of its digits. Here when I talk about number, I mean integers. Now look at the main part. Out here I am accepting a value from the user inside the variable A using the input function, and then I am also accepting another number into variable B. Now look at the third statement over here. P equal to sum A. What am I doing? I am passing the value A, that means the value which is entered by the user, which is stored in variable A, to this particular A. Remember, this A has nothing to do with this A. This A is local to the function sum, and this A is local to the main part. So here I am passing the value of A to this particular function. Here the sum of the digits are happening, and then return the sum. So now the sum is being returned to the variable P. Similarly, the second number is then passed to this variable A. The sum of the digits are being found out, and then its sum is being returned, which is then stored in Q. And ultimately I am displaying the sum of the digits of the two numbers, that is P and Q. So here when I execute it, what actually happens is it gives me a message, enter a number. Say I give 125. Followed by the enter key. When I input the next number, enter another number. Suppose I input 72. Now see what is happening. The value 125 goes to the variable A and 72 gets inside the variable B. So P equal to sum A. So what is happening? I am passing the value 125 to variable A. Now here the sum of the digits are being added and then return S. So what will happen is it's going to add up all these digits, that is 5 plus 2 plus 1, that is 8. And then it will get stored inside variable P. And in the second case, when 72 is being passed, the sum of the digits of 72 is being returned, that is 9, which gets stored in variable Q. So when I display P and Q, it's going to display, in the first case, it is going to display 8, and Q, it's going to display 9. That is 8 is the sum of the digits of 125 and 9 is the sum of the digits of the number 72. Look how practical this particular example is. Now we'll go deeper into it, deeper further inside functions in Python. There is a concept called default arguments in Python. Default arguments means in case you do not pass a value to a particular parameter, it's going to accept this default argument. I'll give you a small example to illustrate this. Now look at this particular function. This is a function definition with a default argument. Here you can see there are two parameters a and b is being initialized with a default value that is 7. That means in case I do not pass any value for b, it's going to assume the value 7. Now come to the main. I'm calling the function named sum. So sum 7. So what happens is the value 7 goes to variable a. And since I did not pass the value for the second parameter, it will assume the default value that is 7. So a will be 7 and b too will be 7 because the default argument of b is 7. So c equal to 7 plus 7, that is 14. Print c, it's going to print 14. Now look at the second case. After that it comes to the next line. Sum 8 comma 9. So 8 goes to variable a and 9 goes to variable b. So now the value 9 is going to override the default argument. That means b is no longer 7. It's going to assume the value 9. So a is 8 and b is 9. Now c is equal to 8 plus 9, that is 17. So print c, it's going to print 17. This is how it works. So in case you do not pass a default value for the default argument, then what will happen? It's going to assume the default value. And if you pass a value for the default argument parameter, it's going to override the existing default value. Now, one point you just keep in mind that all these parameters that is having default values should be placed at the last end of the function definition. So here you cannot have a equal to 7 comma b. You cannot have something like this. All default arguments should be at the end of the function. So you cannot have this. It should always be at the end. That means, of course, you can write b comma a equal to 7. That's fine. But all default arguments should be at the end of the parameter list. Look at the following function definition where I am finding the difference between two numbers. Now note carefully. See out here. Differ a comma b, c equal to a minus b. The name of the function I have named it as differ. So print c, it's going to definitely print the difference between a and b. Now look at this function, differ 12 comma 15. I am invoking the function called differ. So what will happen is 12 goes to variable a and 15 goes to variable b. So c equal to a minus b, that is 12 minus 15, that is minus 3. So print c, it's going to print minus 3. Suppose there may be a situation where you wanted to specify that 15 should go to variable a and 12 should go to variable b. In that case, one solution is definitely write 15 out here and then write 12 out here. So 15 will go to variable a and 12 will go to variable b. But we may use any order if we use the keyword arguments. There is a concept called keyword arguments in Python. This time what we are going to do is we are going to specify, it doesn't matter whatever the order is, we can specify in which parameter which value will be set. So what we are going to do is we can write over here a equal to 17, b equal to 2. Now what actually happens is this time I am calling the function, but this time I am specifying which value is to be going to which particular variable. Now if I specify over here, it is not necessary the first value should be going to the first. You can see I have specified over here a should be getting the value 17. So this a will get the value 17 and b should get the value 2. So this b will get the value 2. This may be written in any order. I can write b equal to 2 and a equal to 17. Although you see the order has changed, that is I have written b and a next, still the value of b, which is 2, will go to this particular b and the value 17 which is assigned to a will go to this particular variable a. So this is how the keyword arguments work. This makes life easier for a programmer. Now there is one more type of function definition in Python which is called anonymous function. Anonymous functions in Python is basically used to define a function without a name. Now this particular function definition is practically very useful if we have a very small definition of a function. That means a one-liner, a function which is having a single line. In such case, we use anonymous function. To define anonymous function, we use the keyword called lambda. So here, what we are doing is, this cube is a name to this particular, you may assume it to be the name for the function, but actually it's a variable. Lambda is used to tell that this is the variable which will be used as a parameter, and here what it is going to do, that is multiply a 3 times, that is find the cube. Now look at the way I am invoking this anonymous function. P equal to cube, this is the name of that particular identifier, and I am passing 5. The value 5 goes to variable a. Now what will happen is a into a, that is cube of this will get executed. That is 5 into 5 into 5. The cube of 5, that is 125, will get stored in P. Now look at the next definition, Q equal to cube 7. So what will happen? 7 into 7 into 7 gets multiplied and stored inside variable Q. And this time the value 343 gets stored inside the variable Q. So print P and Q. So it's going to display, for P it's going to display 125, and for Q it's going to display 343.